Right, so we're going to use that to solve for time. So we know that our distance is negative 74.7. And then initial velocity times time is 1/2 times negative 9.8 t squared. Oh, that should be a plus sign. Sorry. Right, so 0 times anything is going to cancel out. So then we have negative 74.7 is 1/2 times negative 9.8, which is negative 4.9, and then t squared. So for this one, we can just divide by 4.9.
Negative 4.9.
Yes, that's what I meant. I wrote it down. I just forgot to say the negative.
I wasn't looking at the board.
Divided by 4.9. So that's going to give us 15.2. Really, 0.245. Again, you should try and avoid rounding. I mean, it's fine if you like write it down rounded, but I like to keep the number in the calculator and actually take the square root of the whole thing.
And then I just press enter because it's a chalk number.
Yes. Oh, crap. Hold on. This calculator has the buttons different than the yellow one. I have 74.7. Yep, so you should get 3.9 seconds for time. And remember, that works for your vertical, and time is always the same in both directions. All right, so now that we found time, we need to find the range, which is our horizontal distance. So what equation do we use to do that?
Vx
Equals what?
Really? V equals V.
What'd you say, April? Yeah, d over t. Yeah, so velocity is distance over time. So for this one, we know our velocity is 15.27, and we're trying to find the distance, and it's divided by 3.9 seconds. So you're just going to do 15.27 times 3.9, and our range is then 59.6, really, it rounds up, meters. And then what is the last thing we have to solve for? VF. So our...
Hold on a second.
You can use the top one for that, can't you?
What's the top equation?
VF equals VI plus AT.
You can.
You said you can?
Yeah. You can. The only thing that I would hesitate about that with is that you solved for time, so if for some reason you solved that wrong, then you're going to get the other one wrong as well.
You can't really solve wrong for time.
Well, if you make a mistake, you can if you make a math mistake. So you could also use the bottom equation and use the VF squared equals VI squared plus 2AD. Which really, because VI is 0, so that works out fairly easily. But either one, so we can use the top one. We can use the VF equals VI plus AT. So let's do that. So then VF equals VI plus AT. So it's going to be 0 plus negative 9.8 times 3.9. Yes. Wait, why? We're using the top equation.
I know.
Oh, you're using the other one? Yes, so we're using vertical variables if you use the other equation. So then you should get negative 9.8 times 3.9. And get negative 38.2.
Yeah, that was way easier than the other one. And it was shorter. I didn't have to use that extra page.
Yeah, the type 2 ones are a lot shorter. It helps because you start out with more information. You don't have to find the components.
About 30
And then you don't have to factor to find the time either.
Do the max of height.
Yeah, there's not a maximum height either because it's starting on a cliff and just going downward. So.
But with this, couldn't we figure out like what it would be like if it did the other way, right?
Huh?
If like we have half of that, if we had the other half, with all of this, we could figure out what the other half would like would be pretty much.
Yeah, but that wouldn't if it was launching like over the cliff.
Yeah.
Yeah, you could. And there's sometimes where you won't be given that height and you have to solve for it. But the difference between the types is more just like the shape of it. Like so type 1 it's on level ground
Like same
and starts
formulas
an
and
inch.
stuff, it's just
Yeah. And then for these it just goes off a cliff and down.